In this video, we're going to cover surface area of pyramids and cones. So the first formula let's look at is the lateral area, and this is 1/2 the perimeter of the base times the slant height. So the P stands again for the perimeter of the base, and L is the slant height. The total surface area is going to be 1/2 the perimeter of the base times the slant height, so that's the lateral area, plus the area of the base. So when we're given a pyramid, we might have a base that's a triangle or a rectangle or a, looks like this is a hexagon. And then later on, when we get to cones, our bases will be circles. Let's take a look at some examples. The solid below are regular pyramids. Round your answer to the nearest hundredth. That means 2 decimal places. Okay, so first let's start with the perimeter of the base. So the perimeter, we see that we have a triangle here, so we have 3 sides, and each side is 6 centimeters, so 6 times 3, and the perimeter of the base is 18 centimeters. So then the lateral area is 1/2 the perimeter of the base times the slant height. And you can see that the slant height is this guy. This is the L. So in this example, it's 10. All right, if we pick up a calculator and work that, let's see, 1/2 of 18 is 9 times 10. We don't even need a calculator. That's just 90. And centimeters squared. All right, so for your total area then, let's find the area of the base. So the area of the base is 1/2 the apothem times the perimeter. We learned that in our last unit. And so we're going to have to do a little bit of work here. So let me draw, this is the base. And we can see that the sides are 6. And so we need to find this guy. Remember, this is the A, the apothem. So if each of these angles here is 60, this little guy here, 1/2 of that is 30 degrees, right? And here's our right angle. So this is the 30, 60, 90. If each side length is 6, that means this side length here is 3. That's going to be across from the 60-degree angle. So let me write up my little 30, 60, 90. X root 3 and 2x. Across from the 60 is the 3. So x root 3 is equal to 3. So when we divide both sides by root 3, that's just 3 over root 3. Okay, so then that is what our x is. The x is across from the 30, and so that's our apothem. Okay, so I know it's a little bit of work here. 1/2 the apothem. I'm not even going to rationalize it because I'm going to go ahead and put it in my calculator so that I can get a decimal answer. And then the perimeter we said was 18. Okay, let's see. So 1/2 of 18 is 9. And 9 times 3 divided by root 3, that's going to give me about 15.59. So the area of the base is about 15.59. Okay, and so we need that to find our total area, which is the lateral area, which was 90, plus the area of the base, which we just calculated at 15.59. When we add those together, that's going to give us 105.59 centimeters squared. Okay, in problem number 2, we have, okay, so let's find first the perimeter of the base. And so we can see we have a square base this time. And so 14 times 4, and so that's 56. And let's see, we need to find, let's see, so the slant height is 24, so that is going to be 1/2 the perimeter times the slant height Oh, we don't know the slant height. Okay, so on this one, look what we're given. We're given the vertical height. Okay, but you can see that this is a right triangle here in the center. So I'm going to go ahead and draw that so we can figure out what that slant height is. The slant height is the hypotenuse. Okay, so if 14 is the length of the whole side, then half is the base of this triangle. And the vertical height is 24. So guess what? We need to do Pythagorean theorem. 7 squared plus 24 squared is equal to x squared. Okay, so pick up your calculator. 7 squared plus 24 squared, and we take the square root of that, and that gives us 25. So the slant height is 25. All right, now we put that into our calculator. And the lateral area is 700. Okay, so then to find the total surface area, it's the lateral surface area plus the area of the base. And again, the base is a square with side lengths that are 14. So just length times width, 14 times 14 is 196. And when we add those together, that's going to give us 896. And let's go ahead and put the units on it. All right, our next example is this pyramid with a hexagon base. All right, so let's first find, the perimeter of the base. So if I have a hexagon with side lengths that are 8, so the perimeter is just going to be 8 times 6, which is 48. My lateral area is going to be, 1/2 the perimeter of the base times the slant height. And in this case, I am given the slant height, and that's going to be 13. And so if we calculate this, put it in my calculator, I'm getting 312. So my lateral area is 312. Okay, so now I need to find the area of the base. All right, and so that was from our last unit. And the way we did this is we drew in a right triangle. Remember, we needed our apothem, and the area of the base is 1/2 the apothem times the perimeter. So my apothem is 4 roots 3, and we already figured the perimeter was 48. And if we put this into our calculator, I get 166.28. So that's the area of the base being that hexagon. All right, so then my total surface area is the lateral plus the area of the base. And when I add these together, that is 478.28, and these are in feet squared. Okay, next example, we have a pyramid, and it says the total surface area of the pyramid with a square base is 144. Its base edges are 8 feet long, and find the slant height. Okay, so I know, just some little marking this up, I know that that's 4. All right, so the surface area, because that's what we're given, this formula is 1/2 perimeter times the slant plus the area of the base. So if I know that my total surface area is 144, the perimeter is 4 times 8, so that's 32, and we need to find the slant height, and then the area of the base. Since this is a rectangle, I'm just going to go length times width. And actually it's a square, so I could just do side squared. Anyway, I'm going to get 64. Okay, so I'm going to subtract 64 from both sides. So 144 minus 64, and that's 80. Half of 32 is 16. Divide both sides by 16. And the slant height is going to be 5. All right, let's take a look at cones. So the formula for the lateral area of a cone is pi RL. And R is the radius and L is the slant height. The total surface area, well, is the lateral plus the area of the base. And in this case, the area of the base is always a circle. So that's going to be pi r squared. All right, so here's our example. And it wants us to leave it in terms of pi, so we're just going to have a decimal answer. I'm sorry, we're not going to have a decimal answer. Okay, so our radius is 16. The height is 30. Let's see, we have, we need to figure out this slant height right here. So I can go through Pythagorean theorem. Let's call this x. And so if I work that out in my calculator and take the square root, if I add these together, square and add together, that's 1156. And if I take the square root, that's going to give me 34. So my slant height is going to be 34. All right, so then the lateral area is just going to be pi times the radius times the slant height. And when I multiply 16 and 34, that gives me 544, and it leaves in terms of pi meters squared. For the total surface area, it's going to be, well, not T, I meant to write an S, 544 pi plus pi times the radius squared. And so 16 squared is 256. So this is 256 pi plus 544 pi. And that's going to give you 800 pi meters squared.